Good morning, viewers. This is Kasturi Day. Today I'm going to start a new chapter and a new subject rather. That is chemistry, and the chapter is first chapter of chemistry of class 9 syllabus ICSE, and this is the language of chemistry I'm starting with today. Okay, so before I start, I'll ask you to please subscribe my channel so that you can be stay tuned, you can stay with me, and so that I'll be discussing some this ICC pattern questions which I have started with biology also. So you will be able to you can participate in my this videos in this question answers. Okay, and you can get the pattern how the questions of class 9 syllabus are there in ICC exams. Okay, class 9 ICSE exams. Okay, so for that you need to subscribe and also press the like button and share with your friends so that they can also be benefited from these videos, and the like button will be providing me some motivation so that I can produce you some more good videos for you all. And also, if you want a live session to discuss the question answers, please write in the comment box. Okay, so I'll arrange for that. And also please go through the videos. If you have any doubt, please do write in the comment box. Okay, so let me start with my video for today. Okay, I'm sorry, something went wrong. Okay, so I'm starting with, okay. So my first slide will be on introduction. What is chemistry? Okay, so chemistry is a branch of science that tells us what is the matter made up of. Okay, what is the matter made up of, and what is its nature, structure, and what changes are observed when it is subject to different conditions. So it's a branch of science that tells us what the matter is made up of. We see everything which we see on around us is all matters. Okay, so those matters are made up of what? That is found through chemistry, through the branch of science that is known as chemistry. Not only the what is it made up of, but its nature, its structure, and whatever the changes we see when we apply different conditions to it. Okay, now the basic unit of any state is its molecules. Okay, any state that is solid, it may be solid, liquid, or gas. Any state it may be, matter is is found in three states, that is solid, liquid, and gas. And any state it may be, the basic unit of the matter is molecules. As a molecule is the smallest particle of matter that can exist independently. Okay, why is it so? Because molecule is the smallest particle of matter which can exist independently. So why we call molecules the basic unit of any state? Because it is the smallest particle of the matter which can exist independently. The molecules that contain same kind of atoms form a pure substance. Okay, one molecule which contain the same kind of atoms, then it is called a pure substance. For example, carbon dioxide gas is a pure substance, as all molecules of it are made up of 2 oxygen atoms and 1 carbon atom. See, CO2. So 2 oxygen atoms are there and 1 carbon atom in each molecule of the carbon dioxide. So, okay. Then a molecule may contain similar or dissimilar atoms. Okay, like in carbon dioxide, we find similar atoms, and in some other also molecules are there which have dissimilar atoms. A pure substance in which a molecule is made up of similar kind of atoms is known as element. Okay, a pure substance, that's therefore element is a pure substance which has similar kind of atoms. Okay, in a molecule. An element is therefore an element. How do we define element? Element is a simple and pure form of matter that cannot be decomposed into simpler substances. We cannot break the element into simpler substances. It's a simple and pure form of matter. Okay. Next, we come to all the elements are made up of atoms. Okay, all the elements are made up of atoms, and that are the smallest particles of the element, representing all the properties of the atom, of the element. Okay, so I told you that these elements cannot be decomposed into smaller substances, a pure and simple substance, and these elements are made up of atoms, and they are the smallest particle of the element. The atoms are the smallest particle of the element, which represent all the properties of the element. Therefore, what is an atom? An atom is the smallest particle of an element that may or may not exist independently, but can take part in a chemical reaction. But in case of molecule, molecule is the smallest particle of an element which can exist independently. But atom may or may not exist independently, but can take part in the chemical reaction. Okay. This is the basic difference between atom and a molecule. These things we have studied in the lower classes also, just as a revision. I'm doing it. Okay. The number of atoms in a molecule of an element is atomicity. Okay. Atomicity of an element means the number of atoms in a molecule of an element. Okay. For example, it may be monoatomic, it may be diatomic, it may be triatomic or tetratomic. Okay. Monoatomic are noble gases. Then diatomic is hydrogen. See, 2 atoms are there. Then triatomic is ozone, O3, that is triatomic. Tetratomic is phosphorus ion, that is P4. Okay. Then octatomic is sulfur. Not iron, it is atom. It's an element. Phosphorus is an element which has the symbol of P4. So it's tetratomic. Then octatomic is sulfur. It is S8. Okay. Symbol is S8. So these are the different kinds of atoms according to their these are kinds of elements which has different numbers of atoms, which means the atomicity of the element. Okay. Therefore, a molecule is the smallest particle that can exist independently and exhibits all the properties of that element. But an atom is the smallest particle of an element that may or may not exist independently, but can take part in a chemical reaction. Atoms or molecules of an element combine chemically. They can combine chemically, that is atoms or the molecules of an element, they can combine chemically in a fixed ratio to form a molecule of a compound. Okay. When atoms or molecules, they combine chemically of an element, they combine chemically in fixed ratio, they form a pure substance, that is a compound. For example, sodium chloride or water, etc. Different types of compounds we know. Sodium chloride is sodium and chlorine. 2 different kinds of atoms are there combining chemically to form a totally different type of substance or totally different type of compound. Okay. Even water also, hydrogen and oxygen combining to form, chemically combining to form a liquid known as water. But when two or more molecules of elements are combined, when two or more molecules of elements or compounds combine together without any fixed ratio, when they are combining with a fixed ratio, then it's forming a compound. When it is combining without any fixed ratio or without any chemical combination, then it forms a mixture. Okay, so two things between difference between a compound and a mixture. Compound, see, chemically there is the elements has to combine chemically, and in a mixture it can combine but without chemical combination. Second point is that molecules or atoms, they combine in a fixed ratio, but in case of mixtures, they can combine with without any fixed ratio. Okay, this mixture can be homogeneous or heterogeneous. Okay, this can be homogeneous or heterogeneous, not homogeneous and homogeneous, homogeneous or heterogeneous. For example, salt solution, muddy water, etc. Salt solution is a homogeneous mixture where excuse me, where in every parts of water we see salt molecules. Every part of water we see salt molecules in a ratio, in a not only fixed ratio, but the ratio is there. Okay, and the combination is not chemically combining. Even muddy water, some part has more mud, some has less. With water, it is combining, no fixed ratio, no chemical combination. So it's a heterogeneous mixture. Okay, now we come to the elements and compounds are named with abbreviations by using symbols and formula. Okay, the elements and compounds, they are named by abbreviations by using symbols and formula. These symbols started from some pictographic forms used by alchemists from representing the substances used in their experiments before 1600 AD. Example, a triangle formed for the earth, then a half moon like that, a crescent moon rather, it's for silver, etc. So they used some symbols, and these symbols and formulas which they use, these symbols started from some pictographic forms which were used by alchemists to represent the substances in their experiments. When they were used this, they used it before 1600 AD. Okay, then Dalton used some other symbols. Previously these symbols were used by alchemists. Now, when Dalton came, he used some other symbols to represent the elements, like O for oxygen, then a circle with a dot for hydrogen, then an oval for carbon, then phosphorus, a circle was there with three rods were there. So like that for phosphorus, then plus sign covering a circle in between the circle, that is for sulfur, like that. Okay, the symbols, these are the symbols which were proposed by Dalton. See the examples, you can see hydrogen, this is the phosphorus, then copper, there's a circle in between which is written C. Then for gold, there's a circle with dots inside and a G written. Then carbon, a plain circle. Sulfur, there's a circle with a plus sign in between. Then lead, for lead, it's a circle with L written. Then for platina, there's a circle with P written. Oxygen, a simple circle. Carbon, there's the circle is shaded. Okay, but oxygen, the circle is blank. Then for iron, there's a circle with the I written. For silver, so circle, then S written. Okay, and then for mercury, there's a circle with certain dots inside. So these are the symbols which were used by Dalton to represent his elements. Then we come to later on, according to John Jacob Berzelius, the symbols of the elements were represented by the first letter of the respective names in English that are written in capitals. So then after Dalton, John Jacob Berzelius came. He proposed certain symbols which were the first letter of the English alphabet, which were the names of the which were written in the English, and from that the first letter was taken as the symbol for the elements. Like oxygen, O was taken, hydrogen, H was taken, carbon, C was taken for symbol. Okay, but some elements did not follow this rule, as their symbols were based on the Latin names and other language names. So not all the elements were named in English. Some had Latin names, some had other language names. So these symbolic rules were not followed by some elements. Now, this method was the foundation of the basis of IUPAC system. Okay, that is International Union of Pure and Applied Chemistry System, IUPAC system. Okay, IUPAC, the full form is International Union of Pure and Applied Chemistry System of Chemical Symbols and Formula. So antimony, which was named as Latin, it was called as stibium. So the symbol is S capital and B small, copper, cuprum, C capital, U small, gold, aurum, A capital, U small, then iron, ferrum, F capital, E small, lead, plumbum, P capital, B small, mercury, hydrogarium, that is H capital, G small, potassium, kalium, for that is the symbol is K, silver, argentum, A capital, G small, sodium, natrium, N capital, A small, tin, stannum, S capital, N small, tungsten, wolfram, the W is used for symbol in capital. Next, we come to the certain symbols. It is the short form that what are symbols? We are talking of symbols, no? So what is a symbol? It is the short form that stands for the atom of a specific element or the abbreviation used for the name of an element. So we need to name one element, no? How do we know that what is the name? Like when a child is born, we have to name him or her. Okay, so for that, we need to know that, we need to name that element. So for that, some abbreviations is used or a symbol has to be used. The short form has to be used. So that is known as symbol. Okay, each element is denoted by a symbol. So first letter of the English or Latin name is used as a symbol. Like sulfur, S is used, hydrogen, H is used. Okay. Now the elements are denoted by two letters. Okay. We see that some elements have the first letter in common. Okay. So what do we take? We take the second or the third letter as for abbreviation, for naming it with the symbol, making it a symbol. Okay. Like for carbon, cobalt, copper, calcium, cadmium, chromium, chlorine, all have C in common as the first letter. So all we can't say that capital C is the symbol for all those things. So we need to add some more letters to make it symbolize the particular element. For that, see, for carbon, the C is used. Capital C, only one letter is used. For cobalt, capital C, small o. Okay. For copper, capital C, small u from the Latin name, cuprum. Then calcium, capital C, small a. Then cadmium, capital C, small d. The third letter is used. Okay. Otherwise, see, calcium has Ca, even cadmium has Ca. So calcium is named as Ca, but cadmium is named as the third letter is used, that is C and D. Then chromium, Cr, chlorine, Cl, like that. Okay. Next, see, note that need to be very careful about the capital and the small alphabets. Where the capital letter is written and small letter is written, you have to be very careful when you are memorizing and when you are writing it down. For otherwise, the element will change. If the symbol changes, the element will change. Like if you, for copper, if you write CO, then it will become cobalt and not copper. Okay. So what is the significance of these symbols? These symbols, they signifies the name of the element Also, it tells us how many atoms of the element are there. That is, one atom of an element is there. Now, also gives the information of a definite mass of the element that is equal to the atomic mass present in grams. Okay, so the name of the element it is suggesting there's only one atom of the element is there, and also it is giving the information of a definite mass of the element equal to the atomic mass expressed in grams. For example, the symbol of N, capital N, stands for the element nitrogen. One atom of nitrogen is there, then 14 grams of nitrogen is equal to the atomic weight of the element. Okay. So this is the part of the symbols. Okay. So I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. You can also share with my share your doubts in my email ID, that is kasturi74@gmail.com. And also, if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And these like buttons, likes of yours will motivate me to produce some more good videos of my own, so that can help you in your studies much more better. And also, if you want any live session to clear your doubts, then you please write in the comment box. I'll arrange for that. And last but not the least, that you need to subscribe to stay tuned with me and to get connected with me, so that I can give you some suggestions or some discussions regarding the ICSE pattern questions, which I'm discussing in my, I've started discussing in this class, that is class 9 syllabus. Okay. So thank you for watching and have a good day.